So let's get started with 5.1. 5.1, we're going to talk about perpendicular and angle bisectors. Okay. A perpendicular bisector is if you have 2 points here. If I have point A and I have point B, a perpendicular bisector is a line that goes through here as perpendicular to this line and it cuts it in half, right? Hence the bisector, right? Bisector means it's cutting it in half, right? So any point on this line is going to be the same distance from here and here. Okay, in other words, this distance and this distance are going to be the same if it lies on the perpendicular bisector. Okay, and how do you prove that? Well, if this is O and this is C, right, we can say that triangle AOC and triangle BOC are congruent because this length and this length is the same. This length is the same because it shares it. And then these two angles are the same. They're both 90 degrees. So you have SAS, right? Side angle side, side angle side, side angle side, side angle side. From SAS, we can say that this here is true, that this triangle and this triangle are congruent. Therefore, this guy and this guy are going to be the same length. Okay? All right. Now, the converse of this works also, right? So if you look at the theorem on 5.1-1, what does it say? It says, if a point is on the perpendicular bisector of a segment, then it is equidistant, same distance from the endpoints of the segment. From the endpoints of the segment, it is the same distance. So this distance and this distance are the same, okay? The converse says that a point is equidistant from the endpoints if it's on the angle bisector. No, if it's on the perpendicular bisector. Okay, we just proved that. All right. Okay, let's see if we can do example number 1 using this. Example number 1, applying the perpendicular bisector theorem and converse. Find each measure. Okay, we have a like this, and we have W, X, Y, Z. This is the same, we have that, and this is 7.3, find YW, find YW. So this is, since it's on the perpendicular bisector, this distance here and this distance have to be the same, therefore WY is going to be 7.3, and that's simple enough. Okay, the next one, we have like that, and we have A, B, C, D, and we want to find BC. We're given this as 36, this is 36. And we're trying to find BC. This is 16. So we want to know this length of BC from B to C is going to be CD plus DB, right? So this is going to be the same as CD plus DB. CD is 16, DB is 16 because this and this have to be the same. So it should be 32. Okay, and then the last one, we have, they're just, here we have P, Q, R, S, And we are given that this and this is the same. This is 90 degrees. And this is 7n minus 18, 2n plus 9. And we want to know what is the length of PR, right? PR. Oh, we know it's 2n plus 9. We just need to figure out what n is here, right? But we also know that this and this, these two lengths are the same, so I can put them equal to each other. Right? So I need to solve this. How would I solve this? Sarah, can you tell me how I would solve this?
You would find like the common in both sides of the equation.
Okay, so tell me what I'm going to do. What would you do here?
You could add, so you could add 18 on one side, and then the side with the 7n minus 18, you would add 18 and then add 18 on the other side.
So this would go away. 7n, 2n plus 9 plus 18 is 27.
Then you could subtract 2n from the left side and then subtract 2n from the right.
Okay, so I'm going to have 27 is equal to 7n minus 2n is 5n. Therefore, n is going to be equal to 27 divided by 5, correct? Which would be 5.4. Looks like 5.4. That'll be your answer. So that would be the n, right? So if you stopped here, you're not getting full credit, right? You have to now put this back into here to find out what PR is. PR is 2n plus 19, 2 times 5.4 plus 19, right? 5.4 times 2 is 10.8. So it looks like we're going to get 10.8 plus 19, 29.8. Okay, whoops. It's 9, not 19. $19.8. Okay, so that's how you work with the, so that's the perpendicular bisectors. Now let's talk about the angle bisectors. Okay, let's talk about the angle bisectors. If I have an angle like this, and this is what APB, and if I bisect the angle, if I go ahead and cut this angle in half such that this angle and this angle are the same, if I take a point here, any point here, the distance from here to here and the distance from here to here are going to be the same. Okay? So this distance here and this distance. So in other words, if this and this are the same, if this is an angle bisector, right? Because now it's bisecting this angle, okay? The bisecting the angle, any point on there, the distance from here, this line, and the distance from this line are going to be the same. Okay, and how do I prove that? If you look at, if you call this O, we'll say triangle O, we'll call this X and Y. So angle or triangle OXP, OXP, and triangle OYP are going to be congruent, okay? And the reason why they are congruent is because you have a side, and then you have an angle here and an angle here, right? So this angle and this angle are going to be the same because they are both 90 degrees. This is 90 degrees, this is 90 degrees. So angle, okay, so we would say what? So this would be side, angle, side. Angle, side, because it shares this side right here, right? Angle, side, angle, side. So through angle, side, we can say that these two triangles are congruent. Since they are congruent, I can say that this length and this length are the same. Okay? All right. So let's go ahead and read the theorem there on the bottom of page 313. On the bottom of page 313, there's the angle bisector theorem and its converse. See if it makes sense to you. 5.1-3. If a point on the bisector of an angle, if a point is on the bisector of an angle, then it's equidistant from the sides of an angle. If a point is on the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. Okay? Okay, so that's good. Let's see if we can go and use it, flip the page and do example number 2. Example number 2, we have find each measure, and on the first one, looks like we have K, J, K, L, M, and we know that this and this are the same. We know that this guy here is 12.8, and we want to find what LM is. LM, so this is going to be 12.8. Since this and this have to be the same, this is also going to be 12.8. So that was pretty simple. Let's go to the next one. And the next one looks like we have an angle bisector that looks like this. And we're going to go from here, this is 90 degrees, and from here, this is 90 degrees. And we want to find angle 8. Okay, so this is 74. This is 74. A, B, C, D. And I want to know angle A, B, D. So I want to know this angle here. I want to know this angle. Given that angle ABC is equal to 112 degrees. So this entire angle is 112 degrees, but this angle and this angle are going to be the same because this guy is lying on the angle bisector of this obtuse angle, right? You have an obtuse angle, so this angle, ABC, is split in half by this angle bisector. So if they want me to find ABD, it's nothing more than half of the 112, right? Which would be 56 degrees, it looks like. 56 degrees, okay, all right. Let's do the last one. And the last one, I want to find angle TSU. Again, I have, looks like an obtuse angle here. And I have UTSR. I am told these two are the same. So this is an angle bisector. This angle and this angle would be the same. And I've been told that this guy here is 5Z plus 23. This angle here is 6Z plus 14. And I want to find the angle TSU. So I want to find one of these angles. So I can do this and find out what Z is. Okay, so the way I would find out what Z is I would set these two angles together. So 5Z plus 23 is equal to 6Z plus 14 plus 14. Okay, so I'm going to move the 5Z over. 23 is equal to 6Z minus 5Z plus 14. 5z, 16 minus 5z is equal to z, and move the 14 over here. Minus 14, 23 minus 14 is 9, is equal to z. So this angle here is going to be 5 times 9, z is equal to 9, plus 23, 45 plus 23 is equal to 68. 68, so that's going to be your answer. Okay, so that's good. I'm going to go ahead and skip example number 3. Example 3, I'm sure you guys can figure it out on your own. Let's go and jump into example number 4. Example number 4 is a little interesting. Example number 4. In example number 4, I write an equation in point slope form for the perpendicular bisector of a segment with endpoints -1, 6, and 3, 4. So I have -1, 6. This is -1, 6. And I'm going to have 3, 4. 3, 4 here. So I'm going to have this guy. I know this is the segment. And I want to find the angle, the bisector, the perpendicular bisector, okay, which is going to look something like this, okay? So I want to find this line. This is the line I want to find, okay? So, first of all, I can find this point here, right? Because this point is what? What is this point? If this was A and B, this point C is what? This point C is nothing more than the midpoint of A and B, right? Reeve, can you tell me what the midpoint equation is?
It's like x1 plus x2 over 2.
Correct. Very good. So x1 plus x2 divided by 2, y1 plus y2 divided by 2. So this is going to be C right here, right? So -1 plus that is going to be 2. 2 over 2 is 1. 10 over 2 is 5. So I know that this guy here is 1 and 5. So I know this point, all right? I know the point, okay? All I need now is the slope, because it says find it in point slope form. Point slope form, okay? So I just need a slope, right? So how do I find the slope of this guy, the perpendicular line here? Anybody have a clue? Suggestion? Kayla, how would I find the slope of the perpendicular line?
Would you use like the slope formula?
You use a slope, well, I only have one point, right? So I can't use a slope formula right now because I only have one point.
Would
But
you use mid?
I do know the slope of AB, right? I
Mm-hmm.
can calculate that.
So you'd use the midpoint formula?
I did use the midpoint formula for this to find C. Okay, so that's good. We're good with that. So isn't there a relationship that I know that if I know this slope, I can find this slope? Anybody know what that is?
Vertical angles.
What? Somebody said the right answer. I heard it.
Vertical angles.
No, that's not it.
This
Form.
Huh?
Point slope form.
Okay, we need the point slope form. We'll use the point slope. I just need to find the slope, right? Because I have the point. I'm missing the slope. So to find this slope, there's a way to know the slope of this dotted line by finding the slope of this line. What is the relationship between the two?
They're opposite reciprocals.
They are opposite reciprocals. Good job, okay? So if I can find out the slope of this one, then this slope of the dotted line becomes the opposite reciprocal of that slope, okay? So let's go ahead and try to find the slope of AB first, okay? So in order to find the slope of AB, so looking to find the slope of AB is nothing more than 6 minus 4 delta y. Okay, so let's do, okay, we call this point 2, so let's stick with that. So y2 minus y1 over x2 minus x1. Okay? So the top is going to be -2, bottom looks like it's going to be 4, just -1/2. So since the slope of this is -1/2, the slope of the perpendicular bisector must be the opposite reciprocal of this, which would be 2. So I know that the slope of this guy is going to be 2. I know the slope and I have a point now. So I just need to put it into the point slope form. The point slope form was y minus y1 is equal to mx minus x1. It's going through this point with a slope of 2. So y minus 5 is equal to 2, the slope, x minus 1. Okay? And this is your answer. You stop right here. You do not have to put this in a slope-intercept form. As a matter of fact, if you put it in slope-intercept form, you will not get full credit because the question specifically asked for the equation in point-slope form. Okay, so you have to pay attention to the little details here. Okay, the question asks or says to write the equation in point slope form, okay? So you have to stop right here, okay? Even if you didn't see that, this is a perfectly acceptable answer because there are 3 different forms, right? You can have the slope intercept form, the point slope form, or the standard form. Either form, any one of those 3 works, okay? All right, we're done with 5.1.